Hello everyone. So today we'll be discussing about JDK, JRE and JVM. What's the difference between these three? Okay. In Java's ecosystem, these three play a very major important role. Let's understand what is your JVM. So basically your JVM full form is Java Virtual Machine and it is your heart of Java programming language. Okay. So what JVM does is it interprets your bytecode. Once you have your bytecode generated, right, by your Java compiler, when you have your bytecode, you will try to interpret this bytecode into machine code depending on the underlying operating system and hardware, because your JVM is uh, machine specific, right, or operating system specific. No matter which JVM you are using, all the JVMs will understand bytecode. That's what we learned so far, right? So that is the duty of JVM, that it just tries to interpret the bytecode into machine code. Okay. Now each Java application runs inside of its own JVM instance. So for every Java application, there is a new instance of JVM created. This is a very important point. Okay. And now when the application starts, the JVM instance is created. And when the application ends, the JVM instance is terminated. So it provides memory management, security, and also error handling. So these are the points related to JVM. I hope it is clear. And now what is JRE? The full form of JRE is Java Runtime Environment. Okay. So what it does is JRE is a combination of JVM plus some class libraries and some other supporting files like jar files and all. So all these put together along with JVM, that is called as Java Runtime Environment, and it does not contain any developer tools, which means there is no compiler or debugger part of the runtime environment. These things are separate. I'll show you a diagram. It will be more clear. For just as of now, just try to understand these points and keep them in your mind. And JVM runs the program using your class libraries provided in JRE. Okay, so JVM needs the help of these things. So used to run Java programs and not develop them. Yeah, so JRE is just used to run the Java programs and not develop them. That is the reason why it is called Java Runtime Environment. Okay, and the libraries include these jar files, etc. These are some of the examples written. And now, what is JDK? This is a very important thing. JDK means Java Development Kit. Okay, so it is a combination of JRE and developer tools. If you see, JVM is something that is there, and combination of JVM plus some class libraries is JRE, and now combination of JRE with development tools as in your Java compiler, debugger, and applet viewer, etc. All of these developer tools or development tools put together with uh, alongside JRE, they are called as your JDK, which is Java Development Kit. Now this provides all the necessary tools to develop and run your Java applications. Okay, so these tools included in as part of your development tools is Java compiler, which is your Java C, that is your Java compiler, and Java debugger and Java applet viewer. So these are the things. So if you want to write the Java code, you need to install JDK. So JDK is the important thing. Once you install JDK, you will have all your JRE and your JVM, everything will automatically you will get it. So if you only want to run your Java programs, then you need Java runtime environment. Okay, so here's the thing, that JDK contains JRE and JRE contains JVM. Okay, so this is the thing. Okay, now let's go to the next slide. So Java runtime environment, if you only talk about JRE, okay, if you only talk about JRE, inside JRE you have JVM, and along with that you have set of files and libraries, right? So if I have to show you another diagram, so let me show you this. Okay, so this is the thing. So you have this JDK, right? So inside your JDK you have JRE. Okay, inside JRE you have JVM and set of libraries. Apart from this, but not part of JRE, you have development tools, which is Java compiler, Java debugger, etc. I hope now the things are very clear. Okay, now let's go back to the next slide. Okay, yeah. So lifetime of a Java virtual machine, which is what is a life cycle of a JVM. Each Java application runs inside its own JVM, which means if you have multiple Java applications, for each of the application, a separate JVM is being maintained, which means if you run application 1, there is JVM instance 1 created, and if there is application 2, then you have JVM 2 which is created for application 2. If you have application 3, correspondingly you have JVM application 3 created. So that is about this. And now comes the most important point. What is a JIT compiler? JIT compiler is just in time compiler, and using this, um Java achieves high performance. Let's see how it achieves high performance. So JIT compiler, it is part of your JVM, and which is used to speed up your execution time. So it is part of your JVM. This is very important. Always remember that your JIT compiler is inside of your JVM. It is part of your JVM. Okay. And when you compile your normal Java code using your Java C compiler, that will convert your code, normal source code, Java code, to bytecode, which is a dot class file. Now you take this dot class file and give it to JVM, right? So then what happens is your bytecode starts getting interpreted and converted to machine executable code. Now what happens is when you have this code, bytecode, there may be lot of code, um, there may be a lot of code which is redundant, right? So it is, when I say redundant, it is repeating code. So the JIT compiles the code when it is needed, okay, but not before the runtime. That's where the advantage is. That's where the advantage is. Okay, so even before you run it, it will compile all your code in a way that whatever code is repeating multiple times, it will mark hotspots for that. Okay, I'll tell you what that is. So if there is repeated code, instead of interpreting it every time, JIT compiles it to executable code, which is fairly easy and faster. So this compiled code gets invoked directly for the repeated method calls. So hence this increases the performance. Okay, so just let's go through this step by step process, and I'll show you how, with a diagram, how this happens. Okay, you have your source code, you took your Java C compiler and you generated the bytecode, which is a dot class file for your Java code, which is your .java file, right? That is your source code. From that you got your dot class file, which is your bytecode. Now JVM will take this bytecode and it will load these files, and then what happens is it starts interpreting the code. Okay, it interprets the byte code and tries to convert it into machine code. Since it is doing it one by one, this is obviously slow for repeated code, right? So that's where your JIT compiler comes into picture, and it creates and identifies hotspots, basically methods which are called multiple times, and your JIT compiler compiles those hotspot methods to your native code, which is your machine code. And this native code is reused directly so that it's much faster in execution. So that's it about this, and let me go ahead and show you a detailed picture of this. Okay, so now if you see, this is your JIT compiler. Now since we discussed, right, this is your Java code, okay, your source code .java file, and Java C compiler compiles it and gives you the bytecode. This is your platform independent bytecode. Now you can take this bytecode, give it to any machine, any OS, any processor, any platform in general, like we discussed, right? Operating system plus processor is your platform, right? So if you give this bytecode to any of the one, it will still be able, any JVM would be able to understand this. Now once you get this bytecode, you will give it to the JVM, right? And it will load this particular bytecode, and then uh, don't think much about these intermediate steps as of now. We will discuss the JVM architecture in depth in the next upcoming videos. So as of now, come to this stage where you have your just-in-time compiler, JIT compiler. As we discussed, JIT compiler is part of your JVM. So what it will do is it monitors your bytecode execution and compiles your code and tries to find the code which is repeating frequently used. okay, so that it collects that information, okay, does your profiling part and then tries to optimize the things and then generates the native code. If there is anything that needs to be stored, it will store it um, in the registry or kind of a cache, so that it speeds up the execution, and you have your execution engine to which you will get your machine code. So that's where you achieve the high performance, right? And then you have your garbage collector. So the garbage collector is something that we will discuss. It is just to wipe out the memory that is not being used, and while you terminate the program, so it will wipe out all the unused memory, and that's how the termination of your code ends. Okay. And again, the same thing. What is JIT? So just JIT is a just in time compiler. It is a component of JVM that imposes performance by compiling bytecode to native machine code at runtime only when needed. So the benefits are obviously faster execution, optimizes frequently used code. Again, platform independency is still there, and memory management and everything. So that's it for this video. I hope um, it was useful. Thank you.